Hey, AP Calculus. Today we're going to take a look at a couple more examples from yesterday's lesson on the chain rule. All right, so I'm going to go ahead and present and we'll get started here. Okay, so just a quick review. Remember, the chain rule says this. It's useful for if we have a function within a function composition. If we can recognize that a function is a composition of functions, the derivative of that is a composition of the derivative of the overarching function with the input being the g of x, the secondary function, times the derivative of that secondary function. That'll be important for us to be able to move forward here. Okay, so when we apply the chain rule, we want to identify what those two functions are. Okay, once we know what those two functions are, we're going to take the derivatives of both of them, and then we just replace them inside the definition for the chain rule. Okay, quick example is, let's say we wanted to find the derivative of sine of x squared. Okay, that means that the first function, the overarching function, is sine of x, and the interior function, the secondary function, is x squared. Take the derivatives of both of those, we get the derivative of sine of x is cosine of x, and the derivative of x squared, using the power rule, is 2x. That means that the derivative of sine of x squared is just cosine of x squared times 2x, or if we want to apply our commutative property, 2x times cosine x squared. Let's look at one example, though. I'll keep the chain rule in the top right corner there. Find the derivative of y, or dy over dx, if y is equal to e to the negative 10x plus 1. Okay, so once again, that exponential function. So the two functions we have are e to the x and negative 10x plus 1. We want to find the derivatives of both of them. Thankfully, e to the x is really easy to find the derivative. It's just e to the x. And then using the power rule on negative 10x plus 1, that gives me just negative 10. So once again, we replace this inside of our original function. That means that the derivative of y is e to the negative 10x plus 1, because derivative of e to the x is just e to the x, times negative 10. So then our derivative of the whole function is just negative 10 times e to the negative 10x plus 1. Looking at another example here. Let's say we want to find the derivative of the cosine of a quadratic function. Once again, that overarching function is going to be cosine, and the secondary function is what's inside, that's 6x squared minus 3x plus 4. So if we know that much, we take the derivatives of both of them. We get the derivative of cosine is negative sine of x, and the derivative of my quadratic function, 6x squared minus 3x plus 4, is just 12x minus 3. And once again, we're going to apply that chain rule that we see in the top right corner. And when we do that, we get negative sine of 6x squared minus 3x plus 4 times the derivative of that secondary function, 12x minus 3. And because I multiply this sine function by a negative, I'm just going to go ahead and multiply by what's inside the parentheses here, 12x minus 3, and get 3 minus 12x times sine of 6x squared minus 3x plus 4. Stay tuned for another video on how to apply the power rule with the chain rule.